Article 250.4A3 of the National Electrical Code, or NEC, mandates the grounding of metal raceways, enclosures, cable armor, and other non-current carrying metal parts for electrical systems. A pole barn with a steel skin and roof could be regarded as an electrical enclosure if it meets certain criteria. Firstly, it must be a metal structure capable of conducting electricity. Secondly, it needs to be designed to house electrical equipment, such as wiring, outlets, and lighting fixtures. When a pole barn satisfies these requirements, Article 250.4A3 dictates that it should be grounded. Grounding in such instances is generally achieved by linking the metal skin and roof to a grounding electrode system. Common examples of these systems include buried rods or plates. However, there's an exception to the grounding rule outlined in Article 250.4 specifically concerning wood frame structures. This exception directly applies to the wooden frame of a pole barn. In conclusion, based on the NEC, the wooden framework of a pole barn is exempt from grounding requirements. However, the metal skin and roof of the pole barn necessitate grounding on all four corners, provided they meet the criteria of an electrical enclosure. It's important to note that local building codes and other regulations may introduce supplementary requirements for grounding pole barns. Consulting with local authorities is always a good idea to ensure adherence to all relevant regulations. In detail, let's examine the key aspects of grounding and bonding in electrical systems, particularly as they pertain to structures like pole barns. Grounding and bonding are essential safety measures in electrical installations, aimed at minimizing the risk of electrical shock and fire hazards. The National Electrical Code, or NEC, provides comprehensive guidelines on how to properly implement these measures. Grounding, in essence, is the process of connecting non-current carrying metal parts of an electrical system to the earth. This connection provides a low impedance path for fault currents, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly interrupt the circuit in the event of a ground fault. The primary purpose of grounding is to limit the voltage on these metal parts, preventing them from becoming energized and posing a shock hazard to individuals who may come into contact with them. Bonding, on the other hand, involves connecting all metal parts of an electrical system together to create an electrically conductive path. This path ensures that all metal parts are at the same electrical potential, minimizing the risk of voltage differences that could lead to electric shock. Bonding also helps to facilitate the flow of fault current back to the source, enabling the overcurrent protection devices to operate effectively. Article 250 of the NEC is the primary source of information on grounding and bonding requirements. It covers a wide range of topics, including the types of grounding systems, the methods of grounding and bonding, and the specific requirements for different types of equipment and structures. Understanding the specific requirements of Article 250 is crucial for ensuring the safety and compliance of electrical installations. When it comes to pole barns, the application of grounding and bonding principles can be somewhat nuanced. As mentioned earlier, a pole barn with a metal skin and roof may be considered an electrical enclosure if it houses electrical equipment. In such cases, the metal skin and roof must be grounded to provide a path for fault current and to limit the voltage on these metal parts. The grounding of the metal skin and roof is typically achieved by connecting them to a grounding electrode system. This system consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes, that are buried in the earth. The grounding electrode system provides a low impedance connection to the earth, allowing fault current to flow back to the source. The NEC specifies the requirements for the size and type of grounding electrodes, as well as the methods for installing them. In addition to grounding the metal skin and roof, it's also important to bond all other metal parts of the pole barn together. This includes metal doors, metal frames, metal pipes, and any other metal objects that could become energized. Bonding these metal parts together ensures that they are at the same electrical potential, reducing the risk of electric shock. The bonding of metal parts is typically achieved by using bonding jumpers, which are short lengths of wire that connect the metal parts together. The NEC specifies the requirements for the size and type of bonding jumpers, as well as the methods for installing them. Now, let's address the exception for wood frame structures as outlined in Article 250.4 of the NEC. This exception states that the wood frame of a building does not need to be grounded. This is because wood is a non-conductive material and does not pose a shock hazard. However, it's important to note that this exception only applies to the wood frame itself. Any metal parts that are attached to the wood frame, such as metal siding, metal roofing, or metal electrical boxes, must still be grounded and bonded in accordance with the NEC requirements. Therefore, in the case of a pole barn with a wooden frame and a metal skin and roof, the wooden frame does not need to be grounded, but the metal skin and roof must be grounded, and all other metal parts must be bonded together. It's also important to consider the local building codes and regulations when grounding and bonding pole barns. Local codes may have additional requirements that go beyond the NEC, and it's essential to comply with these requirements to ensure the safety and compliance of the electrical installation. Consulting with local authorities is always recommended to determine the specific grounding and bonding requirements for pole barns in a particular area. In addition to the grounding and bonding requirements for the structure itself, it's also important to consider the grounding and bonding requirements for any electrical equipment that is installed in the pole barn. This includes wiring, outlets, lighting fixtures, and any other electrical devices. All electrical equipment must be grounded and bonded in accordance with the NEC requirements to ensure the safety of the electrical system. The grounding of electrical equipment is typically achieved by connecting the equipment grounding conductor to the equipment grounding terminal. The equipment grounding conductor is a wire that runs from the electrical panel to the equipment and provides a path for fault current back to the source. The NEC specifies the requirements for the size and type of equipment grounding conductors, as well as the methods for installing them. Bonding of electrical equipment is typically achieved by connecting the equipment to the building's grounding electrode system. This connection ensures that the equipment is at the same electrical potential as the building's grounding system, reducing the risk of electric shock. The NEC specifies the requirements for the methods of bonding electrical equipment. In summary, grounding and bonding are essential safety measures in electrical installations, and they are particularly important in structures like pole barns. Article 250 of the NEC provides comprehensive guidelines on how to properly implement these measures. When grounding and bonding pole barns, it's important to consider the specific requirements for the structure itself, as well as the requirements for any electrical equipment that is installed in the pole barn. It's also important to consult with local authorities to determine the specific grounding and bonding requirements for pole barns in a particular area. Proper grounding and bonding can help to minimize the risk of electrical shock and fire hazards, ensuring the safety of individuals and property. Let's further elaborate on specific scenarios and considerations for grounding and bonding in pole barns, drawing upon relevant sections of the National Electrical Code. Consider a pole barn used primarily for storage, with minimal electrical equipment. Even in this scenario, if the metal skin and roof are present, the determination of whether they need grounding hinges on whether they could become energized or are likely to be contacted by people. If the metal skin and roof are isolated and unlikely to be touched, the need for grounding may be reduced, but it's still prudent to bond them together to minimize potential voltage differences. Referencing NEC Section 250.104, bonding of metal piping systems and exposed structural metal that are likely to become energized is generally required. This section emphasizes the importance of creating a low impedance path for fault current, even if the likelihood of energization is low. Now, let's consider a pole barn that houses a workshop with various electrical tools and equipment. In this case, the grounding and bonding requirements become more stringent. All electrical equipment must be properly grounded using equipment grounding conductors run with the circuit conductors, as per NEC Section 250.118. This ensures that fault currents have a clear path back to the source, tripping the overcurrent protection device. Additionally, the metal frame of the workshop benches and any other metal objects that could be touched should be bonded together and connected to the building's grounding system. This helps to create an equipotential plane, minimizing the risk of electric shock. In areas with livestock, such as a pole barn used for animal shelter, the grounding and bonding requirements are even more critical. Stray voltage can be a significant concern in agricultural settings, as it can affect animal health and productivity. To mitigate stray voltage, it's essential to ensure that all metal parts that animals could come into contact with are properly bonded together and connected to a robust grounding system. This includes metal fences, water troughs, and feeding equipment. Referencing NEC Section 547.9 specifically addresses equipotential planes in agricultural buildings. This section requires the establishment of an equipotential plane in concrete embedded or exterior to the concrete, which is closely bonded to the grounding system. The aim is to minimize voltage differences in animal contact areas. Furthermore, the type of soil and the presence of moisture can significantly impact the effectiveness of the grounding system. In areas with high soil resistivity, such as sandy or rocky soils, it may be necessary to install multiple grounding electrodes to achieve the required low impedance to ground. The NEC provides guidance on the spacing and installation of grounding electrodes in Section 250.56. In wet or corrosive environments, it's important to use corrosion-resistant grounding electrodes and connectors to ensure the long-term integrity of the grounding system. Copper or copper-clad steel grounding electrodes are commonly used in these applications. It's also worth noting that the size of the grounding conductors and bonding jumpers must be appropriately sized to handle the anticipated fault current. The NEC provides tables that specify the minimum size of these conductors based on the size of the overcurrent protection device. For example, Table 250.122 provides guidance on the size of equipment grounding conductors for AC circuits. Regular inspection and testing of the grounding and bonding system are crucial to ensure its continued effectiveness. Ground resistance testing can be performed to verify that the grounding electrodes are providing a low impedance path to ground. Bonding jumpers should be visually inspected to ensure that they are securely connected and free from corrosion. Any deficiencies should be promptly corrected to maintain the safety of the electrical system. In addition to the NEC requirements, it's important to be aware of any local codes or regulations that may apply. Some jurisdictions may have more stringent requirements for grounding and bonding than the NEC. It's always advisable to consult with local electrical inspectors or qualified electricians to ensure compliance with all applicable codes and regulations. Finally, it's essential to remember that grounding and bonding are not a substitute for proper wiring practices and overcurrent protection. All electrical circuits should be properly wired with appropriately sized conductors and overcurrent protection devices. Grounding and bonding are simply additional layers of protection that help to minimize the risk of electrical shock and fire hazards. In conclusion, grounding and bonding of pole barns require a careful assessment of the specific conditions and intended use of the structure. Compliance with the NEC local codes and best practices is essential to ensure the safety and reliability of the electrical system. Regular inspection and testing are also crucial to maintain the effectiveness of the grounding and bonding system over time. Now let's elaborate on specific grounding electrode systems acceptable by the NEC. Firstly, a metal underground water pipe. This is often the most effective grounding electrode, but it must meet specific requirements as outlined in NEC Section 250.52a. The metal water pipe must be in direct contact with the earth for at least 10 feet or 3.0 meters, including any metal well casing bonded to the pipe. Internal non-conductive sections or coatings invalidate this electrode. Secondly, the building or structure's metal frame, where effectively grounded. If the metal frame is connected to earth through other acceptable grounding electrodes, it can serve as the grounding electrode. This is detailed in NEC Section 250.52 at. Thirdly, a concrete encased electrode. Commonly referred to as a UFA ground, this consists of at least 20 feet or 6.0 meters of bare copper conductor, not smaller than number 4 American wire gauge, encased within at least 2 inches of concrete and in direct contact with the earth. This is described in NEC Section 250.52 A3. Fourthly, ground rings. A bare copper conductor. not smaller than number 2 American wire gauge, encircling the building or structure in indirect contact with the earth at a depth of at least 2.5 feet or 762 millimeters. See NEC section 250.52 FR. Fifthly, rod and pipe electrodes. These are perhaps the most commonly used and consist of rods or pipes driven into the earth. NEC section 250.52 FF specifies the requirements. Rod electrodes should be at least 8 feet or 2.44 meters long and can be made of various materials, such as galvanized steel or copper. The code also stipulates the diameter and installation depth. If a single rod doesn't achieve the required resistance to ground, 2 or more rods must be installed, spaced at least 6 feet or 1.83 meters apart. Sixthly, plate electrodes. These consist of metal plates buried in the earth, as described in NEC section 250.52(6). The plate must have a surface area of at least 2 square feet or 0.186 square meters. Galvanized steel or copper are common materials.